In this video, we're going to take a look at the idea of isomorphism and also how to determine if two graphs are isomorphic. And it's actually fairly easy conceptually to determine if two graphs are isomorphic, because if two graphs are called G and G prime, there's a one-to-one correspondence between their edge sets, and there's a one-to-one correspondence between their vertex sets. And so basically what we need to do is we need to show that there's a one-to-one mapping between edges and vertices. All right, so let's start with an easy example. All right, and we have this set G and G prime. Okay, so I'm going to call this V of G. All right, and I'm just going to have like a set, and in here let's have U1, and then U sub 2, and then U sub 3, and then U sub 4. All right, and we can have a mapping to V of G prime. And so the way it looks to me is if U1 goes to U2, then V1 can go to V4. All right, so we could basically have the mapping over here that if this is going to be V1, V2, V3, and V4, then we would say that U1 maps to V1, U2 maps to V4, right? And then, so the next would go from U2 to U4, and the next would go from V4 to V2. So that means that U4 would map to V2, right? And then finally, the only one that's left is to go from V2 to V3 or U4 to U3. And so that means that U3 would map to V3, all right? So, so that could be a mapping, or if you wanted to write it this way, U sub 1 maps to V sub 1, and then we could have U sub 2 is going to map to V sub 4, and then we could have U sub 3 is going to map to V sub 3, and then finally U sub 4 would map to V sub 2. All right, that could be another way to write it. Right? I'm just going to keep it in this sort of mode just to make it easier for us to see, and that's perfectly fine. Right? Now we have to also show that the edge sets have a one-to-one mapping. And so to do this, what we might want to do is we might just want to label the edge sets. All right, so let's just call this like D sub 1, D sub 2, D sub 3, D sub 4. And over here, I'll call this E sub 1, and then we'll call this E sub 2, and then E sub 3, and then E sub 4. All right, now, because we've defined the edge set, the vertex sets in a mapping, now we're going to have E of G, and we're going to have E of G prime, and those are going to map to one another. All right, so now we know right away we're going from U1 to U2 and from V1 to V4. So it looks like that D sub 1 would map to E sub 1. All right, and then remember we had that V sub 4 to V sub 2, all right, or U2. So that means that this is D2 right here, and then E2. So D2 is going to map to E2, right? And then we have E3, and then we have D3. So we have D3, which is going to map to E3. And then finally, we have D4 and E4. All right, so we have D4 right here, and then we map to our E4. All right, and so that would be our mappings for this. All right, so that's why we show isomorphism, is because we have mapped the edge sets to vertex sets, or the vertex sets to the vertex sets, edge sets to the edge sets. All right, now a little bit tougher example. All right, not too much more difficult, but we have this sort of these two graphs, G and G prime. All right, now we have to be careful with this one because in the first example, every vertex had a degree of 2, so it was pretty easy, and it wasn't necessarily too difficult for us because even if we made a mistake, we could go back through and try to fix it. In this one, what we notice is that there's a few vertices that have degree 3. All right. And so right away, we know that they have to map to one another eventually. All right. So let's just start out with V of G and V of G prime. All right. And so we're going to have a pretty big set this time. So we have like our U1, U2, U3, U4, U5, and U6 for our vertices. And over here, we're going to have V1, V2, V3, V4, V5, and V6. All right, so let's just have the idea that U4 is going to map to V5. All right, so this is going to map to V5. All right, now we have to make sure that we understand that to move in true traversals, to go from one vertex of degree 3 to another vertex of degree 3, one way to do this is just to look at those that have degree 2, and we can get to it in 2 traversals exactly. All right. And there's actually lots of ways to do that. Now here we have to take 1, 2, 3 traversals. All right, to go. So it looks like right here we can go in 2 traversals. So V6 could very easily map to U1. Okay, so we can do this mapping. Okay. And that would take care of this one, and this one, right? And then the only other way that we can be able to get to the vertices of degree 3 in 2 traversals is to go here to here. So that means V4, and then we would have to do this in 2 traversals. So that would mean that V4 is going to map to U3. Right? So we have U3 maps to V4. And then I don't think we mapped V3 to U2 yet. And to go from U4 to U5, so we're moving from U4. Now remember, U4 mapped to V5. So we're here, and we're moving in 1 traversal. All right, so it looks like that V1 is going to map to U5. All right. And then finally, the only that are left, which makes sense because we have U6 and we have V2, and sort of U5 is between U2, and it looks like that we have this one V2 that's between our vertex of degree 3 and then the only other vertex of degree 2 that we just looked at. And so these would map to one another. All right, so that would be our mapping for this. And the only other thing we have to do is we have to match the edge sets to one another. All right, so I'm going to erase this really quickly. And we have to be careful because now that we've defined the vertex sets, now we have to define the edge sets for one another. So we're going to have E of G and E of G prime. All right, so here we go. And here we go. All right, now we know U1 mapped to V6. All right, so let's just circle that. So U1 to V6. Right? And then from U1, we want to go to U2. So let's call that E sub 1. So let's call that E sub 1. And then to go between, we know that U2 mapped to V6. Okay, or U2, excuse me, mapped to V3. All right, so let's call this D sub 1. All right, and what I'm going to do is I'm just going to erase what I've done. All right, so now we're going to go from U2 to U3. Right, so to go from U2 to U3. Now we just said that U2 mapped to V3. And we said that U3 mapped to V4. So let's call this D sub 2, and let's call this E sub 2. All right. And so notice what we're doing is we're just taking the vertices that we just constructed, right? And we're just mapping them to one another. All right. And we're just creating an edge set. right? So we had U3, and remember U3 mapped to V4, right? And we have that U4 maps to V5, right? So we have this and V5. So let's call this E3, and let's call this D3. Right? This is a lot easier, I think, being able to make our own labels than going through and just trying to do it to where there's already predefined, like at the beginning when we define our edge sets. All right, so I just like the weight. All right, so we just had V5 maps to U4, all right? And then from there, let's say we wanted to get back to U1. Remember, U1 maps to V6. All right, so let's call this E4, and let's call this D4. All right. And we're going to erase again. All right, so we're taking care of the perimeter. Now we just have to go on the inside. All right, so we just said that U4 maps to V5. And so to get to U5, we would have to go to V1. All right, so we have this. We're going to call that E5. And V1, that's going to be D5. All right. And then to go from, and then after this, it gets pretty easy because we're just about out of lines here. So we said that U5 maps to V1. Right? So we have U5, V1, and then U6 should map to V2. So we have our U6, which does map to V2. So let's just call this E6, and this would be our, so U6 maps to V2. So this is going to be D6, and then we're going to call this D7, and then E7, and we'll be done. All right, so that's probably the easiest way to do these types is just to wait until the end. 7, that should be a 6, and then we would have, these should be E's, by the way. All right, and so we have an E5, an E6, and an E7, and a D6, and a D7. All right. And so what I would urge you to do, again, is just to wait until the end after you've defined the vertex set isomorphism or the one-to-one correspondence, then take care of the edge set at the end. All right, don't try to define at the beginning the edge sets. It makes it just a little bit easier for you. Okay, so in the last video, we're going to take a look at, in this one, we're going to take a look at trees.